Next part is the Arduino Uno, which is basically the brain of the robot. And this model we also get from online. And as you can see, this board has four pinholes with same diameter, which we can use to pin down the board onto the robot's body. And the measurement is like around 66 times 52 millimeters, with its thickness is around 1.6 millimeters, so a relatively small parts of the robot. Next, to combine and connect together all the parts together, we made some standoff and spin to do the task of connecting the parts together. So we have like this female 40 mm and female 24 mm is the female standoff, and this is all the pin that we use. So basically the for the female standoff is basically just a hexagonal shape extruded to any length that you want, and with a cut off of circle. I think is 5 millimeters in that in both sides to connect with the pin. So this is the 40 millimeter deviation. We also have the 24 millimeter, which is basically you just change the extruded length here. So this is the standoff. Next we have the pin. Also similar concept. We just have one design and just change the dimension based on what you need. So this one is 8 in length, and the diameter for this part is 3 mm. So that's why the name is 8L 3D pin. Another one we have this one, which is 6L, meaning the length is 6 mm, and this diameter is 3.2 mm. So as you can see, we have more pin that we just customize the dimension based on the need of the situation. So like this one, this pin Uno is basically the pin that we use to connect the Arduino Uno with the robot. And this pin motor is what we use with the motor. Next is the body of the robot, or the chassis of the robot. So this one is we design ourselves. So this all these holes that you can see is all for design for all the component that we're going to put on the robot. So like this one too is for the, I believe it was the for the W420 tester. This three is for the ultrasonic sensor. This one is uh, I believe it was yes, stage 7 is for the Arduino Uno. And this back part is for the battery pack, and down here we design a bit of a compartment for the two motors that we're going to put. And the overall dimension for this body chassis is around 142 times 95 mm. We've added some bit of length over here, around 23 mm. So next we also have the just for the Q2. Just this one is to put the motor driver L298 in, and because there is not enough room to put the motor driver on this level, so we made another level to just put the motor driver, which are going to be supported by the standoff. And lastly, we have the assembly of all of the parts. So this is the full robot. We have all the parts that we have mentioned before, the ultrasonic, the Arduino, the motor driver, the case, the tire, the two motors, and the W420 tester. Also the stand-off and the pins. So yeah, as you can see, we have different size of pin which connect all different parts of the material that we use onto the robot. This one is for the Arduino. A little bit smaller for the motor, connected it to the robot, and we make this stand off to level down the W450 tester so that um, the robot will stay at a relatively straight 180 and 150 degree angle. So the robot will not be slanted while it's moving. And just like this, we make the stand up a little bit tall. So like in theory, we will have enough room so that we can uh, take out the case cover. So it will be enough room to put in the replacement battery. So this is the full robot, and also showing the drawing. The robot meet the specification that the patient need, which is its top view has a minimum area of 15 centimeter by 15 centimeters. So we have 14.8 centimeters times 14.95 centimeters.